Hello, I'll just start with a brief introduction. My name is Muna. Um, Currently, I run a little tech blog, Networks by Muna, and I'm currently a network automation engineer at Google. My journey so far, basically I've had a little bit of runs at Lenovo, Facebook, and currently at Google as a network automation engineer, where I majorly just build network solutions. I really love networking world. I got introduced that like in freshman college, and I've just really loved it. And I enjoy explaining it to people, breaking it down, even the basic ones. And that's what birthed Networks by Muna. And in this today, I'll just be going through some basic Linux networking. Today, firstly, just talk about some networking fundamentals, which most people here might already be aware of. Then just seeing how to implement it in the Linux world, and just some minor or key troubleshooting practices that will help. The core goal of this is to kind of reduce the barrier to open source contribution, because a lot of, from college and friends, some people don't have that like understanding of the networking portion of things, and I just thought it would help out a bit. So the first thing will be networking fundamentals. So a lot of times there's this focus on, okay, the compute, like with AI, okay, how large, we need more compute, or we need more capacity, and sometimes there's little to no emphasis on networking, but when there's a problem, everybody points at the network. So all throughout the time of compute, from mainframe computers to data center machines, even to our personal day-to-day communication, the need for these computer resources to communicate is very important and is always necessary, and that's where networks have always come in. And networking topology, the topology, the way things have been done has evolved from like daisy chain looping, where to talk to one device, you have to go from A, B, then to like client-server modes, where there's a central client file server, to more sort of sophisticated architectures like the three-tier architecture, or with the spine leaf architecture that is mostly used in data centers today. So I've seen how that has progressed over time with the key goal of, okay, how can we do it? How can these resources talk to each other faster? How can they talk to them more efficient? And with multiple points of failure. So that was what has caused for these improvements in topologies. So today I'll just be talking about like the basics, like I mentioned. So first is how these computer resources are able to communicate to each other is via addresses. So there's the MAC address, which is the manufacturer inbuilt ID that every device gets from the manufacturer at first, and is mostly used for local network communication between devices that are connected in the same local segment. And then there's the IPv, which is going away, but it's still the very predominant IP address, which is the IPv4 logical address that is used for still a huge portion of the internet, but we know IPv6 is gradually coming to replace it. So IPv4 is like the logical address that for each device to communicate with each other, they get assigned to it based on the network, and they exchange information via, it's like the address of the devices, and to get from one point to each other. And the best way I understood networks, and I like to explain it that way, is like a road system, where your compute is like homes. And so you have like multiple computers scattered in different, they need to communicate to each other. Well, then the network is the highway road, and like the network packets are like cars. So the data goes in the packet, and the packet moves from point A to point B. And then we have, like, in every road system, there are traffic rules, traffic regulations, and that is equivalent to like network protocols and policies that everyone has agreed on, that, okay, to communicate, we use TCP, or we use IP protocols, we use FTP protocol for file transfer. So those are what network protocols are. Then firewalls are like security checkpoints. How if you're moving between states or between countries, there's usually like security checkpoints for security. Yes. So that's what firewalls are, to ensure everybody the intended data is coming in and out of the network. Then, like I mentioned, IP addresses. So we have like public IP addresses and private IP addresses. So like in a enterprise, you could have devices use private IP addresses to speak to devices in the same AS or in the same enterprise. And that's like your street address or your street name, where you can have 3431 Kirkwood, both in Texas and California, and have multiple address names. But when you now want to like move data from like across countries, you have to use more global unique things like the state, the zip code, the country, and that's where like public IP addresses. Yeah, this is what I just mentioned. MAC addresses like your mailbox ID, which is very specific. But then public address is now like globally unique, and it can come from, you can speak to like different devices and globally using the IP address. Then just from network device basic. So like for a device to get connected, for a device to be network aware, it uses the network interface cards, and it can be integrated to the device, or it could be like, it should be connected using the PCIe slot or USB dongle adapters. And there are different ports, RJ45 ports, USB ports, or fiber optical ports. For high-speed data centers, mostly optical ports with fiber optic cables, which, unlike with RJ45 and Ethernet cables, use copper, and with fiber optic cables, you use light, which has like much faster speeds for transferring data. Then just to talk about some essential network services, we have DHCP, which, like I mentioned, each device needs an IP address to communicate within and outside the network. So you could statically assign DHCP, or you could also just use DHCP server. So when a device gets added to a network, it automatically gets assigned an IP address, and it gets sent like everything it needs to know to communicate, which is like the default gateway, its DNS servers. Then DNS is like the computer, is like translation from how computer knows to get to a place using the IP address to what humans know, which is like www.google.com, for example, versus like the actual IP address. Then firewalls, like we mentioned, and ECLs is to permit or allow specific traffic in or outside the network and enforce like rules for security. Then just to now talk about how Linux, how we configure this, we use network interfaces, which are logical representations of like the physical or the virtual network devices. So like I mentioned, we have like the network, the NICs. So we now have network interfaces, which now on basic level is a one-to-one mapping. But when you now talk about virtualization, so it supports that, and we can now have like a one-to-many mapping, where in your server you can just have one physical network interface card, but it can be mapped to like multiple virtual interfaces. Then to configure network interfaces, the easiest way is using the IP command, where you just use IP address show and you put in the IP address. Then if you want to show, so IP address show to show the IP, the IP interfaces. You can do IP route show to show your routing table. But the issue with IP command is that it's when you make changes to the interface, doesn't stay in a reboot, because when you reboot the device, or if the device fails, all the network configs are lost. So the more standard way is to use Network Manager, NMCLI, which saves the configs to a file location, which is to like a file. So when there's a reboot, it just reads the configs from that file back to the interfaces. Yeah, that's like I was talking about, network configuration file locations. And every distribution has its own like location, but it's the idea of just having like a more persistent data storage for your configurations. And then they are different, like for example, for NetPlan, which is a different configuration tool, it saves the configs in a YAML file and uses like the YAML format to store the configs. Then Linux now has its own firewall implemented, which is uncomplicated firewall, which is just a basic way to allow some certain kind of services to within and outside of the server. Like if I'm running a web service, there's no need to be accepting packets from like file transfer protocols and the likes. So you can just filter it based on services to add an extra layer of security to your Linux. Even though most likely you definitely like for your network you need like external and more dedicated firewalls. Then for troubleshooting, sorry, I'm a bit fast. Then for troubleshooting networks, before I talk about like more specific like commands and whatnot, in the networking space, there's what we call OSI model, which is more of a logical representation of the network, which is from physical, data link, network, transport, session, presentation, application. And we use this to troubleshoot issues and to even speak. Like if you're speaking with a network engineer and you're like, oh, this is layer 3 problem, there's an understanding versus, okay, this is a layer 2 problem. So that way, it helps like reduce complexity. So when you're trying to look for problems, it's good to start from like layer 1, the physical layer. Is your cable broken? The lights on? Most times you'll be surprised how a lot of issues people have in their network is just basic things like, the network cut, the network cable cut. And some people might be doing like large troubleshooting skills. So it's always good to first get that cleared out. Then the data link layer, you check, okay, MAC address, is it actually creating local network frames? Can you speak to devices around you? Like in the local network, if you know like a device A is connected to a device B, can they communicate? If they can't even communicate, that means there's an issue. So you now troubleshoot at that level, then you go like to more complicated, like okay, IP address and routing, or then you go to layer 4, okay, the service. Am I allowing the services? Is my firewall correctly allowing the specific services that I need, or is it blocking the service unknowingly? Then you go up and up. So that's the rule of thumb is you fix down, up. So like I mentioned with the layer 1, you can use like some IP link show, like get the specific, the state of specific interfaces. Okay, is the interface up? Because sometimes the interface can be down. So you check, okay, what is the state of the interface? Is everything good? Then you can now check, okay, layer 2, my neighbors, am I able to see them? So with networking, there's what we call address resolution protocol. That's how devices in the local network is able to know the MAC address of their other neighbors. So if you check the ARP table and there's no neighbor there, it shows that, okay, you're not even communicating with the devices physically around you. So you now have to check, okay, why is that not possible? So then even ping, like I mentioned earlier, if you just ping a local device, can you communicate with that? Then if everything works out there, you now go to the next, like, okay, layer 3. That's when you now think of, okay, can I communicate with my default gateway? And the default gateway is like the device's routes to like the gateway out of the network, the local network. So if I can't communicate with my gateway, that's when, okay, there might be a problem. Or can I communicate with outside services? Like you can use trustworthy services that you know that is most likely up. Like you can do like ping to 8.8.8.8, which is like Google's DNS. You can say, okay, is that working? Then separate from ping, we have traceroute, which now gives you a bit more granularity to know where exactly the problem is. As it's when you trace out an IP address, it doesn't just tell you, okay, I can contact it, but it now tells you, it gives you to explain how it works. So with ping, when you ping a device, it says, okay, I reached it in 10 seconds. I was able to get to that device. But with trace out, it gives you at every IP hop, it sends you a message that, I can reach it. So if it communicates with 10 routers from point A to point B, it's going to tell you at every IP hop, I got to this device, I got to this device. And this helps you now pinpoint where there's a failure. So if like you have like multiple routers within your own network, and like if you're like managing a large ISP and you use the trace route, and it's like on the 7th route it fails, you know, okay, maybe there's a firewall incorrectly configured there. Then you can also use the IP route to verify your routing table, to verify the gateway is configured. Because sometimes if your gateway is not configured, every route outside the network will just be dropped. So you have to verify like that exists in the routing table. Then when you now understand, okay, you can access the devices, different devices, then that's when you now start thinking, okay, am I incorrectly blocking a service? And that's like the layer 4 transport level. That's when you now talk about, okay, and like I mentioned, there are protocols and there are policies that the internet community have agreed upon to use. So for like, you have to say, okay, this service, if I'm doing like file transfer protocol, is this service enabled? So I believe file transfer uses UDP. I could be wrong there, it's been a while, but yeah, I think it uses UDP. So you have to now know the exact port number. That's okay. You can use this command netstart with netstart-tu-lmp, and the details are there to give you information on the network segments that are currently listening, to show that okay, you're actually listening for this specific service, and if you're not, you can now make those changes, and then you can now go. Then in the networking world, we kind of group. I know I mentioned 7 layers, but when it's outside the layer 4, most times it's no more a networking issue. So we kind of do. You see networking engineer, they'll say layer 1, 2, 3, 4, then they say layer 7, because we round up all that to like, because that's where you now say, okay, encryption, you can now see like more service-specific characteristics that might not be, is now kind of out of scope of the server. But you can now, in Linux, you have some commands to help like troubleshoot that, because sometimes DNS server, you might be receiving like DNS packets and all, but the service itself might have issues. So you can have to now test those services with dig and put a host name, or NS lookup. You can test to verify that DNS service is working. Then you can now also use the call command, wget, to now test application level connectivity. So then there are other commands like TCP dump. TCP dump is if you want to get if you want to read the packet information and just analyze it. So you can TCP dump for an interface and an IP, and every packet that arrives on that interface, you're going to extract that, and you can now use that on like you can now use that on like Wireshark or other network analysis tools to now see, okay, what exactly am I receiving? And then you can also check logs. That is also like a very good standard practice to do. Then the thing about using these commands is that it can now be very repetitive, where okay, you do ping, then you do IP address, then you do trace routes. So most times what people recommend is just you create a bash script and you just have all those commands listed. That way you can just have like, just run one command and you have like a detailed output on the state of the network. What I do on my end, my personal side, is I have some bash scripts where I just get a report. So once something is no issue, I just run it and it gives me like a detailed report, and it passes out some unneeded data that I don't need. So it just gives me like the IP address state for some specific ports I know are important. It does some ping tests, it does some checks the route table, and I parse out, okay, is the default gateway configured? It gives me the default gateway and things like that. So that's where automation comes in. So I wanted to do a demo, but I wasn't able to set that up. But I dropped like a simple bash script where if you copy this and run this, you check the IP address, the interface status, the IP routing table, the TCP and UDP ports that are being listened in. You verify the DNS. And most times, if all of this are working, it's most likely not a network issue. So this is like a quick way to just if something's not working, you just run this, you see the output, and you know like everything is good or not. Yeah, so just to give a summary, in this talk, we spoke about the network fundamentals, trying to understand that networking is very needed, and most times you don't need to be like a network engineer to do your work, but it's very good to have the basic understanding and know what is happening with your network, because it might just be something very menial that might cost you hours. So that is very good to understand. Then we also went through like some useful commands on the Linux side on both how to configure it and to troubleshoot it. And my goal for this conference is just give people like a little more insight to like networking and more, hopefully even go into it a bit more. I have a blog, Networks by Muna, where in my spare time, I just try to explain some networking concepts. Still a little, I have a lot of drafts I have not yet edited in, but I have a couple that it's been nice reads just to understand basic network concepts. And you could always just check for the commands that I spoke, like NMCLI, IP. They are very powerful commands that you could check their manuals to get like more detailed information. Thank you for attending. Any questions? Okay.
What's the current thinking on tools like Nmap? I've been in jobs where they warn you, don't use it, we might fire you.
Yeah, so even with, okay, I have to repeat the question. So the question he asks is like, what's the problem with things like Nmap, right? Yeah, so even where I work, I can't give too much, but we even don't use like a lot of those analysis tools. We build our own majorly because of the scale. So I've actually not used Nmap in a long time, but most times the issue with some of those, they might not be accurate, and some of these older ones, they are still older tools, they are still being, what's it called? Improved upon. Like NetStart was formerly used, now they use SS. So most of these older ones, they might not be accurate, so I just avoid it. Like at my current company, we use like inbuilt services to actually just monitor our own traffic. So that's another thing that's one of the things I do, yeah. I think I'll answer the question.
I mean, just following up, for me, Nmap is the easiest way to know what's open on a system.
Yeah, true. Yeah. Yeah, I think maybe you ask them, maybe your company has like more specific reasons why they might want you to avoid. Maybe it's not as secure, or maybe, yeah.